Here are our first three log laws. Log law number one. Just like with powers with the same base, you add the exponents. If you have logarithms with the same base, and you're multiplying inside a logarithm, that's as same as adding two logarithms. So the example that I showed you there before, I said, what is log 4 of, go ahead, I actually had log 8 of 4 plus log 8 of 16. According to this, we have the right-hand side of the product law. Everything is matching up with the right-hand side. The bases are the same, and we're adding two logs with the bases the same. According to your log law, this is the same as multiplying them together inside the log. And if I did that, what's 4 times 16? That's 64. And 8 to what exponent is 64? 2. It's 2. So it works with our pattern. So kind of like identities, your log laws are going to be, sometimes you're like, ooh, I want to combine them to a single log. And sometimes you're multiplying inside of a log and want to expand them as adding two different logs. So you can use them like identities. If you have the left side, you could change it to the right side. If you have the right side, you could change it to the left side. What you have to be able to do is recognize when you have something in one of these forms. Right? So, product law for exponent laws, right? If you're multiplying and you have the same base, you added the exponents. Product law for logs is similar, but if you're multiplying inside of a log, you can write it as adding two separate logs. Quotient law for powers, if you're dividing two powers with the same base, you could subtract the exponents. Now, if you're dividing inside of a logarithm, you could write it as two logarithms subtracted. And what was the power law for exponents?
Multiply.
You multiply. So if you have a power to a power, you would multiply. We have the same law in logs, but here, if you have an exponent inside the log, you can bring it out in front and multiply. So in powers and exponents, you have a power outside of a power, or you have an exponent outside of a power, you multiply. Now if you have an exponent inside of a log, you just bring that exponent out in front and multiply. So all of these laws are connected to each other, and all of these are on your formula sheet. So what we do in section 5.5 is we just get really good at using the laws without any context. What we're developing in this unit is skills first in what a logarithm is, what our log laws are, and once we develop those skills, then we can apply it to questions that we weren't able to solve before. Like, we'll be able to apply it to questions like, how do I solve this equation? I couldn't solve that before. I still can't solve it yet. But once I get really good at my log laws, I'll be able to solve this. So first, getting good at our log laws. Example number 1. Take out my highlighter. I want you to highlight that simplify. And we'll define what simplify means for logarithms. in all of your log laws, and they're up on the board over there as well, the left-hand side is considered the simplified side. The right-hand side is considered the expanded side. So basically, when a question says, can you simplify, you're wanting to write it as one single logarithm. In other words, in each of these questions, we have to recognize, do we have the right side of one of those three formulas, one of those three log laws, and could we write it as the left side? So for A, do you see that you have the right side of the product law? The product law says if you're adding two logs with the same base, and both of those have no base written, no base is written, that's a base of 10. If you're adding two logs with the same base, that's the same as combining them inside by multiplying. And 7 times 8 is 56. The second one. If you have a number outside of a log, that is your power law. A number outside of the log can always be moved in as an exponent. So I can rewrite this one. Oops. Log base 10 of 2 to the 5, which is equal to log of 32. And in C, if I have a log minus a log and the bases are the same, that's my quotient law. Subtracting two logs can be combined as a single log by dividing. And 18 divided by 16 is 5. So now I can get you to do some mental math. Okay? I'd like you to do that in your head. Keep about, without a calculator, keep about 7 decimals in your head. Okay? Then I would like you to do this in your head. 10 to what power is 50? Also keep about 7 decimals in your head. Once you've got the 7 decimals in your head for this one, and the 7 decimals in your head for this one, add them up and tell me what you get. No calculator. What'd you get?
2 times 15 is 100. The answer is 2.
Answer's 2. So you're saying you cheated? You didn't find the 7 decimals? Because it's way easier to cheat on this one. Do you see what he did? I kind of led you down the wrong path. Nobody would be able to do 7 decimals in their head. Well, not nobody, but almost nobody. Log of 2 plus log of 50 is a log law. I could combine those together to be 2 times 50, which is 100. When no base is written, there's a little 10 here. Can you do the mental math now? 10 to what power is 100? It's 2. So sometimes combining it as a single logarithm will let us figure it out. Whereas if I just gave you log of 2, knowing that as a decimal, right, would be something you'd have to like memorize if you wanted to know it. So if you're really bored this weekend, Here we go. I don't know if I have it memorized. In my head just right now says 0.102. I don't know why, but that's what my head told me. 0.301. Okay, so I don't have it memorized. And maybe I'll remember it now. I don't know. Useless things. I shouldn't remember things like that. Okay. Questions for practice on this one? You can circle questions 4 and 12.